Alright, so I thought I'd go through the review guide with you guys in a video, because I know some of you guys are really stressed about this test and it's going to have a big impact on your grade. So anyway, for this first one, what you want to do is write the equation, graph the equation. So what we can do here is find my vertex. That's how we do it from standard form. So I do that by doing negative b over 2a. So negative b over 2a is going to be negative 9. So that's positive 9 over 2 times 2. That gives me 9 4. So that's the x-coordinate of my vertex. And to find the y-coordinate, all I would do is plug that in to my original equation and solve for y. So 2 times 9 4 squared minus 9 times 9 4 minus 35. So you would solve that, and again, you would have a calculator, so you'd be expected to do that by hand. Now, are you going to get something this complicated on the test? No, but you should still be comfortable working with fractions like this. So if you do that, you would end up with negative 41.125. Now this would be the only place where it would be alright to have a decimal. So now what we're going to do is go ahead and graph that. I won't do that because it's not going to come out pretty. But again, it's going to be much nicer on the test. This problem was kind of not the best example. So that's 2 and 1/4, so that's here, and negative 41 we'll just say it's here. So here's where that point would be. I know it's going to open up, and from here you could just plot some points. So maybe plot 1 and 3. You could even find 0. 0, you know it's going to be a negative 35. That gives you 1 point over here. And then that's how you would get your graph. That's pretty. And if this had worked out, if the problem had nicer numbers, you could have based it off that original graph of x squared, which goes over 1 up 1 in both directions, and then over 2 up 1 2 3 4. So when you're doing this, all you do is you multiply the a value 2 by whatever the change in y is. So you would go over 1 up 2 instead of up 1, and over 2 up 8 instead of 4. So all I'm doing is multiplying that change in y by my a value. Number 2 is a little nicer. This gives us the equation in vertex form. So for this, I know my vertex is hk. That's going to be 1 7. So 1. That's actually, I think I can put in a graph for this one, and it'll look better. So I have 1 7. Let's see. Over 1, up 1, 2, 3, 4, 5, 6, 7. And now I see my a value is negative 3. So I'm going to go to the right one, now down 1 times 3, which is 3, in both directions. And over 2, down 4 times negative 3, which is negative 12. So I'll be down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on both sides. And then that would be my graph. Now, this is probably going very ugly. Normally this would go through the points, obviously. And that's that. To graph from intercept form, I'll go ahead and put in the graph again. You're given your zeros. So here they give me my zeros are 3. They're P and Q. See if I can get this working. So those are 3 and 7 are my two zeros. You take what's in here and set it equals 0, and you get 3 and 7. So I have 3 here, and 7, 3, 4, 5, 6, 7. And then to find the x-coordinate of my vertex, I just find the midpoint of those. So I just add them together, divide by 2. So that would be 10 over 2, which is 5. So the x-coordinate of my vertex is 5. So I know it's going to be somewhere along here. And then to find the y-coordinate, I just plug it in to my equation, y equals. So you'd get 4 times 5 minus 3, which is 2, negative 2. So that's negative 4, negative 16, so it's going to be all the way down here somewhere at 5, negative 16. Ugh. And then you would just connect. Again, I'm not going to be able to fit this all on here, but we'll just pretend. And that would be your parabola. All right, now here we want to use factoring to solve for the equation for x. Here you should notice that this is a difference of squares. X squared minus b squared equals 0. So I know I can make that ax minus b, ax plus b. So here I have 36x squared minus 25, so that becomes 6x minus 5, 6x plus 5. And then I would just set each of those equal to 0 separately and solve for x. So here I would get x equals 5, 6, and then 6x plus 5 equals 0, and x equals negative 5, 6. You have to be careful to follow the directions. Here it says solve for factoring, so I factored. I didn't solve using square root. Here, this would just be a typical ACB method problem. So I would write my ACB. AC is going to be, let's see, that's 30 and 18 is 48, negative 48 and positive 8. So I want to find two things that multiply to negative 48, add up to 8, positive 8. So I think that's going to be positive 12 and negative 4. So I would get 3x squared plus 12x minus 4x minus 16 equals 0, and this is where I group. Remember, make sure I don't lose that negative. So I can factor out a 3x, and I'm left with x plus 4. Factor out a negative 4, x plus 4, and that equals 0. So now I have my outside, my factors, and then what I was left with from the inside, I just write that once. And then I would set each of those separately equal to 0. 3x minus 4 equals 0. So you get x equals 4/3 from the left and negative 4 from the right. And that would be your final answer. Here you solve each equation using square roots. So this is what we're going to do when it's not in standard form, or it doesn't look like I'm going to be able to complete the square or anything like that. The first step here is just to isolate whatever's being squared. So I want to get x by itself. So I subtract 3. I get negative 1/4 x squared equals negative 8. Multiply by negative 4 over 1, the reciprocal. And I'm left with x squared equals 32. Now I want to take the square root. Remember, as soon as you put that square root in the problem, you need to put that plus or minus out front. 32, the factors of 32, 16 and 2. 16 is a perfect square. So x equals plus or minus 4 square root of 2. Those are your solutions. 7. Again, I want to isolate what's being squared. Here, that is x plus 4. So I want to divide by 2. I get x plus 4 squared equals 18. Square root both sides. Again, once I put that square root in, I need plus or minus. Square root of 18 is 9 and 2. You get x plus 4 equals plus or minus 3 root 2. And then I just subtract 4. So I get negative 4 plus or minus 3 root 2. And that would be my answer. Here I want to solve, so now I just need to decide how to solve it. And this one isn't really in standard form. It looks more like vertex form, so I'm going to use square roots to solve. So I'm first going to isolate what's being squared. So negative 5x plus 1 squared equals negative 9. Divide negative 5. So I get 9/5. Take the square root. So I'm left with x plus 1. I guess I don't really need that parenthesis there. Equals plus or minus the square root of 9 over 5. And here I can subtract 1. But the square root of 9/5, I know the square root of 9 is 3. So I can simplify that. I can first make it root 9 over root 5. So then I get negative 1 plus or minus 3 over root 5. And then if I want, I could rationalize that by multiplying by root 5 over root 5. I get negative 1 plus or minus 3 root 5 over 5. Here we just want to perform the given operation, so this is just testing your knowledge of imaginary numbers. So the first thing you would want to do is just distribute the 5. So you get 10 plus 15i minus 1. Oh, I'm sorry, that's being squared. But we have to be careful here that this whole part is being subtracted. So I want to put a parenthesis there, square the first, double the product, square the last. Now this negative has to be distributed to all three of those. So you get 10 plus 15i minus 1 plus 4i minus 4i squared. I can combine like terms. So 9 plus 19i minus 4i squared. But remember, I squared equals negative 1. So that's really 9 plus 19i minus 4 times negative 1. So that's plus 4. So I get 13 plus 19i. And I need to be sure that I leave that in standard form. So which is a plus bi, which it is. 10, this is just distributing again. So I get 24 plus 18i minus 8i minus 6i squared. So I'm left with 24 plus 10i minus 6i squared. Again, I squared equals negative 1. 24 plus 10i minus 6 times negative 1. So that's minus minus. I get 30 plus 10i. To rationalize the complex number, that just means to multiply by the complex conjugate. So I multiply by 5 plus 2i over 5 plus 2i. This bottom, we can recognize that is just going to be a difference of squares. So I'm just going to be left with a squared, which is 25, minus b squared, which is going to be 4i squared. In the numerator, I do have to distribute. So I get 10 plus 4i plus 15i plus 6i squared. Then I would just combine like terms and simplify. So 10 plus 19i plus 6. That I squared I can change to negative 1 over 25 minus 4. Again, I squared becomes negative 1. So that's going to be 4 plus 19i over 25 minus negative 4. So that's going to be 29. Oh boy, that's hard to read. 4 plus 19i over 29. And we would want to write that in standard form. So we can split that up to 4 over 29 plus 19 over 29i. Makes a difference. When it says absolute value or magnitude, remember that's just the square root of a squared plus b squared. Just b, not including the I. So this would just be the square root of 6 squared plus negative 2 squared. It becomes square root of 36 plus 4, square root of 40, which I can take out 4 and 10. So that would just be 2 square root of 10. Here it wants us to complete the square. So the first thing I have to do is get an x squared plus bx form. So x squared minus 5x, I'm going to subtract 1. Then I add b over 2 squared to both sides. So x squared minus 5x plus negative 5 over 2 squared equals negative 1 plus 5 over 2 negative squared. So as soon as I do that, I complete the square. This on the left just becomes x plus b over 2, which is negative 5 halves, squared equals negative 1 plus the square of a fraction. You just square the top and the bottom. So that's 25 over 4. I simplify that by making negative 1 negative 4 over 4. So I get x minus 5 halves squared equals, that's going to be 21 4. Last couple of things, I would now take the square root of both sides. Square root of both sides. You get x minus 5 halves equals square root of 21 over 4, remember, plus or minus. So now I can add 5 halves. So I get x equals 5 halves. Now 21 over 4, root 21 over 4, I can make root 21 over root 4, which becomes root 21 over 2. Here I want to convert to vertex form. So the first thing I would do is just find my x squared in my vertex. Remember, vertex form is a, x minus h squared plus k. And my a value is the same as it was from standard form. So I know that's going to be 2, so the only other thing I need to find here is my vertex. So that's negative b over 2a. So negative 8 over 2 times 2 is going to give me negative 2. So that's the x-coordinate of my vertex. To find the y-coordinate, I just plug that back in. So I get 2 times 4 is 8 minus 16 minus 10. So that looks like it's going to be negative 18. And then now I have everything I need. So y equals 2, x plus 2, that sign changes, squared minus 18. Now we get into the quadratic formula. The first thing we need to do is write this in standard form. So it becomes x squared minus 3x plus 10 equals 0. My discriminant, remember, is just b squared minus 4ac. That's the portion that's underneath the radical. So that's going to be b squared is negative 3 squared minus 4 times a is 1, c is 10. So I get 9 minus 40 equals negative 31. Now my discriminant is negative, so that means I have two imaginary solutions. If it was positive, I would have two real. Whoops, I guess I was supposed to write imaginary there. And if it was 0, I would have one real. So now I can go through and write out my whole quadratic formula. X equals negative b plus or minus radical b squared minus 4ac, which I just found was negative 31, all over 2a, which is just 2. Negative 31, I'd take out that negative and make it I. So I get 3 plus or minus I root 31 over 2. And if I really wanted to be picky, I would write this as 3/2 plus or minus I root 31 over 2. And those would be your solutions. Here we just use the quadratic formula. So again, first thing we have to get it in x squared plus bx plus c form. So I'm going to get combined like terms, and I get x squared minus 4x minus 2 equals 0. Then I just have x equals negative b plus or minus radical b squared. So that's negative 4 squared minus 4ac. So that's 1, negative 2, all over 2a. So x equals 4 plus or minus the square root of 16 plus 8, 24, over 6. 24, let's see, has 3 and, not 3 and 4, 6 and 4. They go into it. So x equals 4/6 plus or minus 2 root 6 over 6. And now I can simplify. X equals 2/3 plus or minus root 6 over 3. And that would be my answer. Here we want to solve the inequality graphically or algebraically. First thing I want to do is find my zeros. This one's nice and easy. Things that multiply negative 15 add up to negative 2 is going to be negative 5 and 3. So that gives me my zeros of 5 and negative 3. I can draw my number line. I have negative 3 and I have 5. I'm going to pick a test point in between those two, 0. Plug in 0 and I get negative 15 is less than 0. That's true. So I have open circles here. I shade in the inside. So I have negative 3 is less than, not equal to, sorry, is less than x is less than 5. And that is the solution to the inequality. This is what we've done recently. So given a point and a vertex, write the quadratic function. And I can write this in vertex form. So I have y equals a, x minus h, which is 1 squared, plus k, which is 3. They give me the 0.25, so I'm going to use it and plug it in to solve for a. So I get 2 minus 1 squared plus 3, that's 1. So I get 2 equals a times 1. I subtracted 3. So a equals 2. So my final answer would be y equals 2 x minus 1 squared plus 3. This time they give me my x-intercepts. Now we have to be careful when I put those in, the sign changes. So that's going to be x plus 6 and x minus 7. And you're given a nice pretty point, 2, negative 80. So I plug that in. Negative 80 equals a. 2 plus 6. 2 minus 7. So negative 80 equals a. That's 8 times negative 5 is negative 40. Divide by negative 40 and you get 2 equals a again. So that worked out nicely. 2x plus 6, x minus 7. And that's your equation. This is the one that I said is not going to be on the test because you're not going to be able to use your calculator. Here we get to a word problem. It gives me the equation, and it says the horizontal distance is x and the height is y. So it first asks how high can it jump. So in order to know how high it can jump, I want to find the vertex, and that's the y-coordinate of the vertex. So to do that, this is in essentially ax squared plus bx plus c form. My c is just 0 because my initial height is 0. So I can find the x-coordinate of my vertex by doing negative b over 2a. So that's negative b, so negative 4 over 3 over 2a, so 2 times negative 2 over 45, and that ends up being 15. So the x-coordinate of my vertex is 15. To solve for that, I plug it back into my original, and I would get negative 2 over 45, 15 squared, plus 4/3 times 15. So I would solve that. And again, the numbers would be very manageable. So the maximum height would then be 10 feet. To find how far it could jump, what you want to solve for is your zeros. So you would set y equal to 0, because that's when it's going to leave the ground and hit the ground. So negative 2 over 45 x squared plus 4/3 x. The first thing I can do here is factor out an x. So 0 equals x. Negative 2 over 45x plus 4/3. Then I would just want to set each of these separate equal to 0. So I'd get x equals 0. That's where it starts. I know that's a 0. And 0 equals negative 2 over 45x plus 4/3. Subtract 4/3. Multiply by the reciprocal. Let's see. So this can become 15 and 1. That's negative 60. So 30 equals x, and that would give me the distance that it can jump. Here, this is the basic, or not basic, but the typical parking lot problem we've talked about. The first thing I want to do is find out what the area of that old lot is, so I know what I have to set my new lot equal to. So to do that, I'm going to do this big area of the old lot. So 165 plus 75 is 240 times 375. And again, your numbers are going to be more manageable. So I do that, and then I'm going to subtract that by 165 times 300, and that's going to give me the area of just my old lot. 240 times 375 minus 165 times 300, and you should get 40,500. I think we've seen this problem before. So since this says the lot, I want to double the size of the old lot, the expanded lot has to be the same size of the old lot, and that will make it double. So to find this, so far I know that this big area here is 90,000, and the old lot is 40,500. So the thing you always do is the larger area minus the smaller area. So my larger area, is 240 plus x, or x plus 240, times 375 plus x. And then that's this whole area, and I need to subtract from that 90,000, which was the area of my old lot and school combined. And I know that has to equal 40,500. So again, like I said, these numbers will be more manageable, but what I believe you end up getting is x squared plus 615x plus 90,000 minus 90,000 from above equals 40,500. So then this would cancel. I'd subtract 40,500. That equals 0. And then I would factor this again, like I've said. These numbers are going to be more manageable. I believe what it was, though, was 675 and 60. Yep. So you would get x minus 60, x plus 675, and then clearly you would get x equals 60. So they would need to expand the lot by 60. So the big thing to remember there is that you just have to do the larger area. Once you find out what it needs to be set equal to, you do the larger area minus the smaller area and set it equal to whatever that is. So hopefully this was helpful for you guys, and I know you're going to do great on the test.